Hello, welcome back to Cracking the Cryptic, and fascinating. Well, Simon's asked me to have a go at a Mixo puzzle today, and a bit nervous. We'll see how we get on. Mixo, not known for setting straightforward puzzles, in my opinion, and we'll see if I'm right about that, I guess. It's called Ancient Altar. I guess it's designed like a kind of bird's eye view of an altar, maybe with a sword on it or something. Brilliant. Anyway, looking forward to having a go at that. It's all about entropic lines. Those are the yellow lines. I will explain the rules in a moment, but I will also explain that on Patreon we have Simon's incredible solve of Crux by Jay Dyer, a 2-hour, 40-minute plus video. I mean, that's longer than any movie I've been to see for a long, long time. And it's a serious undertaking and a very impressive solve. If you are with us on Patreon, and why not if you aren't, have a look at it. It's extraordinary, but put some time aside. Put a little time aside as well. You might need a bit longer for Demono's brilliant puzzle hunt, or Sudoku hunt, called Solver in Sudoku Land, a whimsical story of a pint-sized Sudoku solver. And you can get to the answer phrase by solving the Sudokus as you go. You can get to the various stages of the story that way. It's brilliant. Give it a try. It's really interesting. Classic Demono stuff. And you can go to his website, demono.ca, where you can catch up on his first story that was on Patreon and has a Kickstarter, which you might have missed. Anyway, let's have a quick run through the other things we have going on. We have our apps, which are all on the description links under the video. Line Sudoku features quite a number of entropic lines, so this might be good practice for some of those. And that is the newest one out amongst our suite of apps, which include Gas as well. Genuinely approachable Sudoku is Gas. And of course there's Sven SUDOKU PAD and our merchandise. Check out the links. But the first link is to this puzzle, Ancient Altar by Mixo. And the rules are these. Normal Sudoku rules apply, so we'll be putting 1 to 9 in every row, every column, and every 3x3 box. Any 3 adjacent digits along a yellow line include 1 digit from each entropy group, but that just simply means 1 low digit from 1, 2, 3, 1 middly digit from 4, 5, 6, and 1 high digit from 7, 8, 9. So that applies to that group of 3 and that group of 3, etc., including that group of 3, this group of 3. Now there are some 2-cell entropic lines. And all we can say about those is that the digits have different entropy. There's not going to be 2 from the same set of either 1, 2, 3, 4, 5, 6, or 7, 8, 9. Now, then we have a couple of black dots which have digits with a ratio of 2 to 1, so one of them is half the other, and a couple of white dots, and each of those dominoes has a difference of 1 between its digits, so they're consecutive. Oh no, wait, we have a diagonal line which has to have no repeats on it. So that'll be a set of the digits 1 to 9. And that's a bit of an optical illusion actually when you look at that diagonal line. Something about the center of the line and the way that the yellow cells look a bit like arrows on it suggests to my brain that it's kind of dipping in the middle and coming upwards towards the ends. I don't know, maybe that's just in my own brain. Anyway, do have a go at Ancient Altar by Mixo. I am going to see what we get. Let's start now and let's get cracking. I don't know how to start this, but well, there are so few dots, it's about the entropy. Right. Okay, so sorry, the simplest thing to do is to take the big line and to colour it. Right, let's go red, yellow and blue for contrast. So every 3 cells along it must be the same entropy. Now, what am I talking about? What I'm talking about is consider these 2 cells which must have different entropy. And imagine this is from 1, 2, 3 and this is from 4, 5, 6. Now to make up the set, this red cell would have to be from 7, 8, 9. But to make up the set for these 3 cells, this one would also have to be from 7, 8, 9. And you can kind of alternate every 3 steps around a line doing that. So I knew before I started highlighting around this line that its length must be divisible by 3, and so it proved. What was I going to do? Red, yellow, and blue for contrast. There we go. So those are shared entropies. Is that telling me anything? It's telling me that for row 2 and 8 and columns 2 and 8, there are 3 reds already in those rows. So the other cells in the row must be blue or yellow, and that applies here as well. And that applies in these columns too. It seems to be reds only that I have the information about. Now, on a black dot, we could have 2 cells. Oh, I mustn't think about modular lines. I must think about entropic lines. We could have a 1 and a 2 would be the only way they could share an entropy. Because 2 and 4 are from different entropic sets. 3 and 6 are also, and so are 4 and 8. But that doesn't really prove anything. The white dots, they're quite likely to be from the same entropy, but they don't have to be. They could be a 3, 4 or a 6, 7 pair. Now, this is the next longest line, but if I start colouring this, I don't know which is red, which is yellow, and which is blue. I know something. This line has 1 of each on. And the whole diagonal, because of the entropic line we're sitting on here in the central box, the whole diagonal has therefore got its 3 reds fulfilled if you include the middle bits, because there must be a red amongst them. And therefore, these remaining cells on the diagonal are yellow and blue. And now look, now I don't know whether this cell is yellow or blue, but I can 3-step it around its line. Oops, nearly miscounted there. And then, yes, look, it's different from this. That's exactly what I wanted to find. This one I can 3-step back the other way along the line, copying what it is. And the remaining cells on the line are now red, because we must have red every 3 along the line. Okay, there we go. And now I've got a red triple in the column. So everything else in this column is now not red. I think I'm going to end up with a lot of yellow and blue with this method. Now that doesn't give me anything I can put here, because as we said, these don't have to be the same. They're likely to be the same, but they don't have to be the same. Okay, I was going to say this doesn't really help unless we can find 6 yellows and blues in one row, column or box. And here they are, 6 yellows and blues in box 3 and in box 7. So the other cells, we must have 3 reds in every row, column and box. Are we going to get, oh no, we're not going to get a a diagonal pattern of reds everywhere. Certainly not in box 2. We might in every other box. No, well, that wouldn't be possible, but anyway. Now, this is not red, this is blue or yellow, because we've got 3 reds in row 7, 3 reds in column 7. Now we can put the 3rd red in box 9. Oh, this is weird, this puzzle. This wasn't what I was expecting to do at all. I've only just realised, how are we ever going to turn these into numbers? Like, it's all very well doing colouring everywhere, but it's going to be the dots that tell us the numbers. And how are they going to tell us enough different numbers? I don't know. We shall find out. But I don't know which of these is red. I've got 5 blue and yellows in this row, but that's not enough to make a deduction. I don't know. These could be the same as each other. Then they would be blue and yellow, or they would be... I don't know. There are some other oddities that, I don't know, I haven't really investigated this. These two are the same as each other because of the three-step rule along their line. And that means that together with these, they use up either all the yellows or all the blues. And these two then end up being the same as each other. I really don't have a clue how to use that. Do I have to do individual colours? Oh, you've got these row 8s. That's already got 2 blues and 2 yellows on. So these are different colours. One is blue and one is yellow. The same's true there, the same's true there, the same's true there. Ah, right, okay, I'm going to the letter tool now, because I've just noticed, yeah, these three are different from each other because of the diagonal line. They all see each other in some way. So 2 of them see each other vertically, 2 horizontally, and the other pair on the diagonal. So they're all different, right? So we're going to call this one A, and this one B, and this one C. And then this has to be the red B. This has to be A. This one we can do as well. That is C, because it sees A and B. So this is A, this is C. Now we can do this, because it sees C and A in its column. That's B. This one now sees A and B. Oh my goodness, this is madness. That's B, this is A, that's C, this is B. This is crazy times. That is C, it sees A in the row and B in the box. Oh, there has to be an A in one of those two. This one is a B. Look at the diagonal. We need a C, a red C on the diagonal. It can't be there because of that cell. Look at that. That is genius. This is Mixo all over. What an insane puzzle. Then we do some Sudoku. We need a C in column 6. It's got to be here. And this one is not red. Oh, this is brilliant. I'm loving this already. This is not red on the diagonal. Now we need a C in this row, and I think that's got to go here. This is amazing. I mean, I love discovering stuff like this. It's so randomly Oh, I've got a problem. Okay, I've got a serious problem because I made that C when it wasn't. So we will just cycle all the way back, but I know what I'm doing. I think this will still work. That should have been B, and that is C. And now, I hope none of this is undermining, well, I mean, it all undermines the actual letters I was putting in, but I don't think it undermines the principle. So that's now C, that's A, that's C. Right, that was the ones we'd done. Now, oh, hang on, we need a C on this diagonal. It's not unable to be there. It's now unable to be there. I'm so sorry. I'm a numpty, but there we go. You live with that every day, and I do too, and so does my poor wife. That is where A goes in row 6. Okay, it's very similar principles. Oh, look, B in box 5 now can't be here and has to be there. Oh, this is crazy. A is in one of those two, so that is blue or yellow. It sees A, B, and C, so that is B in column 6. That is blue or yellow. I'm going to at least colour this with its reds, I think. Well, maybe that was hubris. These are not red. There is a red here. It is red C. And there is a red C here. But oh, B over here has to be in this cell. Then these can't be red at all because they see A, B, and C. These must both be red. Yeah, we are going to finish the colouring. A, B, that needs to be red, I think. This one isn't. We must be able to do these last two. That is not A, B, or C, and that is C. And look, we've ended up with, oh, hang on, that's blue or yellow. I've missed a couple of cells. There we go. That's all the colouring. But we've ended up with a pair of the same entropy. I won't say the same polarity, but I'll keep using entropy on the same black dot. That is a 1-2 pair. Yeah, it has to be. So A is a 3. Can we highlight them? We can. We can whack in 3. Look at that. We've got 9 digits. We've had a party in the southeast corner. Oh, I'm loving it. I'm loving it. So let's put 1, 2 in the other cells. Right. Now this is on a black dot with a 1 or a 2, but it's not a 1 or a 2. So C becomes a 2. I think I have to do my own highlighting on C. C is a 2. And the cell it's connected with is a 4, and these B's are 1s. And we've done all the reds. That's brilliant. Right, let's get rid of red colouring. Hang on. There we go. We've done all of those digits, just like that. That's fun. These white dots are not very helpful yet, but that black dot gave us a 4. But I don't know which of blue or yellow is which. I'm tempted to get rid of all the blue-yellow shading and just leave the known blues and yellows, because the only point of well, okay, I am going to get rid of all the blue-yellow shading, because the only point of doing it, as I was about to say before I interrupted myself, was to identify where red was. Well, it wasn't why I was doing it, but it worked. Now, we've got this long line coloured. I'm going to colour this line, but not in blue and yellow. Let's use green and orange and see if we can use that to work out which colour is which. If we can work out which of green is yellow, which of green and orange is yellow and which is blue, that will help. I don't really know how we do it. These are different because of the line. These are, there's pairs, aren't there? Green and orange are one of each, blue and yellow are one of each, so that's one of each. So that must be orange, because in this box there's one of each there. We just worked out there's one of each there, so there must be one of each entropic set there. And the only opposition we have from that one is with that one, so that must be green versus orange. These are now both orange, aren't they? Because they see 2 greens in the row. Oh, this is weird. I'm going to have to try and get my head around this colouring. This, yeah, similar to row 6. Column 6 has 2 oranges and another one in either yellow or blue. So the remaining cells are green. That's one of each. We did this before in row 2 and row 8, column 2 and column 8. There's one of each on the perimeters. But I'm more getting value out of the places where 2 of the same colour see each other. So here we've got 2 oranges already in the box. That has to be different from orange because of this entropy line. And this has to be different from orange because of this entropy line. So that's green. That's orange. Now we've got 2 oranges in this row. They go green. This is weird. I'm going to get more green and oranging done. 4 has now become orange in this row because it can't be green. Wow. Okay, so the oranges are 4, 5, 6. But I still don't know what blue and yellow are. Or do I? Now, that's a pair, 1 of each green and orange. This is a pair. So this is 1 of each. Blue and yellow is 1 of each, so that is orange. And that's in column 8, so that is green, because that has to be in opposition to the one at the top. Now that's a pair, this is a pair, so that's orange. I could have done that from the column. This is very interesting. This is a pair, because we've got a pair there, green and orange, a pair here, yellow and blue. So this is a pair, but they straddle a boundary between the entropic regions. That has to be a 6 and a 7, 1 from the middling group and 1 from the higher group. And that's 1 of each. I weirdly don't know which way they go, but I know that is in opposition to that. That is in opposition to that. Now that's 1 of each, that's 1 of each, this is 1 of each. That's a domino, that's opposite to that, so this is green. That makes this orange in this row. This is a weird colouring puzzle, and that's green. Okay, that's good. Now, these are they the same? No, they're opposite to each other. We've got 2 greens and 2 oranges on the line. But these 2 are therefore opposite to each other, because this is a pair and this is a pair. I did not think we'd get this far with the colouring without knowing how yellow and blue related to the rest of the puzzle, but here we are, struggling along, trying to work it out. Now, we've had 3 oranges and 3 greens in this row. Hasn't done much else. Okay. These are different. Oh, that's gorgeous in a way. Right, because this is a pair that are different. They're a domino, 1 of each in the box. They're a domino in the box, but they're a domino on the line. So these are 1 of each, and they're sitting opposite these 2, which have to be the opposites of these 2. So they're 1 of each. And since those 2 are 1 of each, this pair is 1 of each. I don't know how that helps at all. Oh, that's really annoying. I thought we were coming up with something there. Oh, can I rule this out from being a 6-7 pair? Now, I tell you what, we worked out that 4 was orange. So orange is 4, 5, 6. So let's do a little bit of... Can we do any more? Oh, maybe we can't. No, because I don't know whether orange is yellow or blue. Oh, that one's not 6. Because of the 6-7 pair. This puzzle's getting stranger by the minute. Now, what does this pair? This just means they're different. It doesn't mean... This one is the one that means they're connected. Now, I was wondering if this couldn't be a 6-7, if this had to be the same colour. Ah, look, okay. I'm going to have to go with another set of colours. I'm sorry about this, but I worked out those were different from each other. So I'm going to go with bright blue and purple here. That is different from the bright blue. So we've got a third set of contradistinct colours. But I'm interested now because this is a pair. Oh, no, I thought it was going to tell me something about these. No, it doesn't. Okay, that is too confusing. We won't do that. I've changed my mind again. What do we do, though? I don't know. I mean, we've got to use this white dot, otherwise we're just... Oh, look, this is a 7, 8, 9 set. I mean, I don't know that that's actually very interesting. All of greens... Ah, that is 7, 8, or 9. Okay. I mean, I don't know enough about these individual greens. No, I don't. To know... It would be brilliant if I knew that these three were different numbers, were each one example of 7, 8, 9, but I just don't think I can trace that sort of stuff around the grid at all. Okay, but it's interesting, if this was 7, and therefore green, this wouldn't be green, but this being green would make that 7 touching a 6 as well. And that doesn't work, because they would both be 7s touching a different colour. That would put 2 6s here, and that would mean that you'd need a third 6 somewhere in those cells which are unavailable to hold a 6. That's incredible. So this is not a 7, this is a 6, and is coloured orange. This is a 7 and is green. Now that's not... Oh, it's telling me this is green and that one of those two is an 8. It's telling me, since that's a pair, this is orange. We've got the 2 oranges in this row, that's green. Oh, and I just worked out that that was different from the corner. Do you remember that? Since those two are different, therefore those two are different, therefore those two are different, therefore these two are different. So that's orange. And now, can I prove this isn't a 7? Maybe. If it was, I don't know. Where's 7 on the diagonal? Well, no, I don't know that. That's no good. Sorry if you're shouting at me. I need to be just very careful about how I go about this, because it would be very easy to just make a misassumption about how this works, and I don't want to do that. Right, that 7 says that these don't have 7s in. Oh, this is 6. That's the only place can be orange 6. Now, I don't know that that's 6, because yellow might be orange, but this is a 5-4 pair. That's 4 or 5. I don't know. I mean, again, I'm kind of left wondering, how can this actually ever finish? It finishes because I just need to be cleverer. So I've got that as a pair, that as a pair, and that as a pair. They're the only cells I haven't coloured at all. But I don't see how they're going to tell me about yellow and blue. And which colours out of orange and green they need to be. Unless I can find, you know, again, I have to find a triple of actual numbers somewhere, somehow. Okay, that's not a 6, is it? So this digit has to be in one of those two. 6 is in one of these two. It almost feels definite to me that there isn't enough information. I mean, obviously that isn't true. This is 4, 5 on the diagonal. So in this, because of that 6, in this row, one of those is a 6. I don't think this can be a 6. Yes, it could. If blue was orange, that could be a 6. Okay, calm down. That is 4 or 5. Can that be the other of 4 or 5? Yes. In fact, can this be orange? Because again, we'd have 6 and 7 here. Now, no, we wouldn't. They're not white dot joined. They're only joined by an entropy difference line. Oh, I don't know. What's going on? Do I need to... colour the... name the greens with letters. Can I do that? I can stop that being a 7 just by Sudoku. One of these is... I don't think there's enough information from 1 7 in the grid. I feel like the 2 6s is a slightly better bet. Just because there's 2 of them, but I don't know how to use them. I can't understand this puzzle. One of those 2 is a 6. If it was that one, that has to be a 6. That's not true. If it was, yes, it is true, because 6 would either be, 6 would be orange. So in fact, these 2, are they the same digit? No, because orange can be blue. The whole conclusion is not true, because those 2 could be the same. Wow. Okay, let's try this. If that was a 5, then this 4-5 pair here is going to mean that has to be a 5. So if this right-hand one is a 5, I don't know. Then 6, that becomes a 6, and that has to be 6. So if that's a 5, orange is blue. And then that has to be a 5. So if this row 5, column 7 is a 5, we're getting 5s in these positions, and orange is the same as blue. So that's a 5. And 5 is needed on the diagonal. It's going to have to be there. That's going to be 5. And there's no, that is complicated, but there's nowhere for 5 then in column 3. So if this is 5, now how did I work this all out? Because I want to just recheck this. Yes, then that becomes 6. And then by Sudoku, that is 6. So blue is the same as orange. And once blue is the same as orange, I think I got it wrong. No, then that is 5 in box. If this is 5, that is 5 in box 9. Then that is 5 in box 8. This is 5 in column 2. 5 is needed on the diagonal there. And now, incredibly, that is 5. And there's nowhere for 5 in column 3. Wow. That's mental. If that's in the path, that is advanced colouring. It's right. Do post what's neater at this point. To me, that's incredibly neat because it's so clever. that forcing it one way or the other kills it. I love that. But anyway, that's now a 6 because it couldn't be 5. So that's 5. Now, we may not be much further advanced. Oh, we get 4 there, 5 here. We may be further advanced. That is not 5. Now, one of these is 6. Now I don't know which one. We need 5 on the diagonal in one of those cells. And they both see this, which is not a 5, therefore. This is not 5. So that's a 4, 6 pair. So 5 in this column is in one of those two. Still don't know which of blue or yellow is middly. 6, 6. One of those is 6. That hasn't changed at all. One of these two is 4. That's sort of by Sudoku. And that's quite useful because that means this is 4. Now, where's 5 in this column in one of those two places? Where's 4 in this column? Well, in one of those two? Yeah, I can't be any surer. These are from 5, 8, 9. Oh, this is right. This isn't speculative. We are definitely right at this point. It's just still not easy. The diagonal. Come on, think about the diagonal. That is 5, 7, 8, or 9 as well. What about these two? Oh my goodness. Okay, one of those is an 8 by Sudoku, so that's not an 8. That's very, well, not by Sudoku, by white dot rules is what I should have said there. This is head-wreckingly complicated, and we're not finished at all. I kind of get the feeling that there's no point trying to do the yellow and blues either and work out which is which yet. We need to kind of fall into that somehow. But I don't think I'm stumbling very hard into it. One of these is a 5. And one of these is an orange 5 or 6. I need to find a cell that all of 4, 5, and 6 are looking at, don't I? So that it can't be that, and that is as yet unresolved otherwise. That would be really helpful. I can't see it happening any moment. If that was a 6, that would be 6. Oh, interesting. Okay, either that is a 6 or that is a 6 in column 3. If that's a 6, that's not, obviously. Well, no, one of these two is a 6 in the column. That could be the 6. Otherwise, this is a 6. And then in this bottom 3 rows, that becomes a 6. And that becomes a 6. So now in row 2, 6 is definitely in one of those two places. And that means none of these can be 6. And that only leaves one place for 6 in box 2, which is there. And now 6 is in one of those two places because it can't be in any of these cells. And it can't be there. I thought that was a really good deduction, but it's done nothing. It's done absolutely nothing to resolve the rest of the puzzle. One of these, no, I was going to say one of those is an 8. That's not necessarily true. One of these three is a 7. Now, if yellow was green, this could be a 7. No, I don't know. That's not the trick. Gosh, just need to think about this a bit more clearly somehow. I was going to get all excited about 4 in the central column, but I've got a 4-5 pair there. That is unexciting officially at this point. One of these two is a 6. One of these two is a 5. I hadn't noticed that before. It's definitely true. And there's an X-wing on 5s with that. But also it's looking at that cell, which is not a 5 now. So 5 in this box is in one of those 3. 5 on the diagonal, we know, is in one of those 2. Come on. If this was green, it would be 7 or 9. That would be 5. That would be 5. That would be 5. 5 would be yellow, so that would be 5. And that, and we've obviously got some 5s marked in the grid already. 4, 5, 6 are yellow at this point. So, ooh, okay, this doesn't seem to work because of those. Right, this is simpler than I was thinking. So if that's green, and 7, 8 or 9, then the 3 greens are used up down here and that's a 5. Oh, no, I just left that cell highlighted. That was the start of the chain. It didn't work. Oh, bother. But if this cell is green, we get 5s here, here, and that's actually fine. 5s are already there and there. Maybe it's not at all straightforward. One of those is 5. Well, it's not the green one. So 5 would be there and there by Sudoku now. And I don't think that would have told me what colour was what. Yes, it would. It would make that a 5. So 5s would be yellow. And we'd have placed all the 5s like so. If row 1, column 2 is green, the 5s end up in these positions. It looks far too feasible. Now, the alternative is that this is orange, in which case this is the 5. Oh, so I should have left that highlighting. Bother. Okay, but just think, if this was the 5, then we get a 5 here in column 1. We've got these already. And we know, do we know the colour? Yeah, 5 is orange. No, I don't know the colours of yellow and blue. But one thing, so I've either learned that 5 is there or there, and therefore this is not 5. That seems to be the only thing I have learned. It's also not 6. So if blue is orange, this is a 4. If blue is orange, then we get 4s in these positions. and there. I don't know. I feel absolutely none the wiser for this. How is this meant to be working? Right, let's go again. If this blue is a 6, we've got 6 here, so that's a 6. Let's just highlight those other 6s, fill in remaining 6s. One of those and one of those. But blue is a 6, so yellow can't be. So that would be where 6s went. If this blue is a 6. So let's just mark those with a letter if I can. Let's call them A. That's where 6s go if blue is a 6. If yellow is a 6 in column 3, then that's the 6. That is again, that's interesting. If yellow is the 6, we get those positions. Now the overlap seems to be in this cell, but I'm going to use that. So if yellow is the 6 in column 3, then that's the only place for 6 in box 7, and that's 6. But if blue is the 6 in column 3, now how did it work out that this was a 6? So we already had those positioned. That becomes a 6. That's a 6. I mean, it's much more complicated. Oh, but 6 can't be in yellow, so that is a 6. Right, that is a 6 either way round. And I mean, I'm sorry, but that's what it takes. 6 there, 4 in the corner now. That's just Sudoku. This is now not a 4. I don't know. Is this going to get us home? Probably not. That was the overlap cells for 6s. Now, there's that. One of these is a 4. That is just definite. I don't know. I can't have done 4 on the diagonal. These aren't 4s. So 4 is there, but if 4... Oh, no, look. 4, 4. That is a 4. Right, we've done it. Yellow thus becomes orange because of 4s. Blue becomes green. And here we go. Now we can finish. That's a 4. Just naked trio Sudoku. Whoa, this is monstrous, this puzzle. Anybody who thinks this isn't hard, I don't know how they're doing it. But I think I can finish off my triples now, or most of them. No, this has to be 6. That's where 6 goes. 5, 5, 6. That is a 6. So how am I doing for 4s? I've got them all. How am I doing for 5s? I've got some of them. Let's see how I'm doing for 6s. I've got them all. So all the 4s and 6s are in. So now I just have to place some 5s. Oops, 5s I said. So we need 1 in one of those 2. We need 1 in one of those 2. And we need 1 in one of those 2. I don't know how to do that. That's really annoying. Okay, let's do... there's an 8 in one of those because of the white dot. So this is a 9. Now that's a 7, 8 pair. That's 7 or 8. Come on, that's made this an 8. This is 8 or 9. I'm really hoping this gets it done, and I'm really not certain it will. That can't be a 7 anymore because of the 7, 8 pair. This also isn't a 7. This is 5 or 9. These are from 7, 8, 9. This could be 5, 7, or 8. That's so irritating. Not finished yet. Right. Okay, come on. Think carefully. Think slowly. Let's just try and get this done. I've used all the dots as far as they can be used. The diagonal, maybe I haven't used that as far as it can be used. One of those two is an 8. And they both see that cell, which is not an 8. One of those two is a 7. That is no use. 9 can be almost anywhere on the wretched diagonal. 8 has to be in one of the... Oh, this is... No, 8 can't be here because it's a different polarity, different entropy. So 8 is definitely here now. And not there. 8's in one of those two and one of these two. And it's not here. 8 is now in one of those two and not on the diagonal. So the 8 on the diagonal has to be down in the corner. So the other corner is where 5 is on the diagonal. That is 9. I can colour those two green and that one. And this one is orange, I think. And this one is orange and is a 5. This is a 7, 9 pair. I'm going to finish now. 8, 9, and I'm going to breathe a big sigh of relief when this gets over the line. That has become a 7 touching a 5. This is a 7, 8 pair. That's a 9. Come on. Come on. That's not 9. One of those is 9, so that's not 9. The diagonal is finished. Bother. The dots are finished. So it's just Sudoku. And it's just the greens. I've done all the oranges. My goodness, how can it still be hard, or at least challenging yet? Oh, 7 is looking to, it can't be. 9 there, 7 there. That's a 7. We're just taking it nice and easy. 8, 9. That's an 8. This is a 7, 9 pair. 9 is here. This is an 8, 7 pair. That's a 7, 9 pair. This is a 7. There we go. 8 there. 7, 8, 7, 9. What a puzzle. 50 people have solved that in the last week. Well done. Well done, people. 49 minutes. I'm not ashamed of that solve time at all. And that step in the middle with the 6s was very, very difficult. I don't know if that's necessarily on the solution path. Mixo's probably not quite that cruel. But it's an insanely clever puzzle, and I've enjoyed it an insane amount. Thank you, as always, for following us on the channel. It's been absolutely fascinating today. Hope to see you again soon, as always. But bye for... Oh, no, hang on. That's the wrong button. Here we go. Bye for now.